Namaste. So, in the last video, I was talking about the concept of expert systems. It was something very, very active, and lots of commercial investments were also done on building expert systems for a wide range of applications during its peak time. Why I got fascinated by this field of expert systems was two things. One, I already mentioned to you that the knowledge is very visible and something that almost everybody can understand. Okay, so when you say if condition and then action or then conclusion, it is something that most people can relate to because a lot of our day-to-day knowledge is also expressed in that form. If you see this red signal, you should stop. If there is a vehicle coming from here, you should turn or whatever. So these are very common things. And so with any kind of representation, in this case, if then rules, you need something which can actually read it and interpret it to solve a problem. So two things. One, there must be something that can read what is written in that representation and also use it to solve a problem, because if it is just a recall, it is of not much use, right? Like textbook knowledge, you should know how to apply it in practice. So for these if then rules that actually led to some interesting ideas. So this was called generally you can say the mechanism to make use of that representation is what is called reasoning. So temporal logic has temporal reasoning capabilities, spatial logic has spatial reasoning capabilities, and so on. Okay, and so if then rules, there were two ways to look at it. So when you say if something, some conditions, then conclude, you could be using it to check whether that conclusion is applicable to a particular case or not. So I want to know whether you have viral fever, for example. Okay, or I don't want to know whether the machine has this particular fault. How do I check it? I pick that rule which concludes that and check the conditions of that rule. And if the conditions are true, then I can infer the conclusion. So if you have hundreds or thousands of rules, obviously I'm not going to go through all the rules randomly or in any particular sequence to do a problem solving. That could actually be very slow. It would be good so if I am thinking that this could be the problem through whatever guess that I have, and I want to establish it, or I want to work towards it, I may look for rules which conclude something and conclude that thing which I am looking for and check the conditions of that rule. Okay, so and the condition itself may require additional information. To, for example, I want to know whether the person is diabetic, or whether he has a prior history of surgery or whatever, and that may not be obviously known to me obvious. So I may either go and ask the person, or there may be other rules which will infer that. So from this establishing that, or to checking whether you have the particular disease, there is a sub problem which is to establish whether he has let's say hypertensive, or he has a kidney problem or whatever, for which there may be more rules. So you start from your goal, which is to check something, look for a rule which concludes that goal, and check the conditions. If the conditions in turn requires you to do additional inferencing, you look for those rules which can help you to make that inference, and so on. So from goal, you work backwards to the data. Okay, so naturally this is called backward chaining or backward reasoning, and this is one way of making use of these rules. There is another way of looking at these rules, which is you can guess it is to go forward from the data. So sometimes I don't know what could be my actually the goal. For example, if you're looking at planning or scheduling problems, I can't have a particular schedule in mind and say, to check whether that is true. The schedule has to be constructed, and lot of inferences, lots of conclusions have to be put together to build a schedule. So I will look at all the data I have, look at any rule which can succeed with the data that I have, and then I can make the conclusion which is given in that rule. Right? And this conclusion might enable more other rules to become applicable and become successful. So from data, you look for rules which can be satisfied with the existing data, fire them or make the conclusions true for those rules, and again you repeat, maybe there are more rules which are now become eligible to fire, and fire those rules, and so on till you reach what the configuration or a planning problem or whatever. So anything, something of a constructive or where the goal is not very clear, you can use these rules in a forward direction. And if it is if when you're looking to establish something which is like what you do in a classification case, you can use the rules in the reverse direction. Of course, there are cases where reasons where you want to do both of this. For example, when you walk into a clinic and the doctor basically has no particular information about you, the initial symptoms and your whereabouts, your demographics and all that can be used to fire some rules in the forward direction to establish, to kind of guess, make some guess about what are possible things that may happen, and then you try and use the remaining rules in the reverse direction to check whether those possibilities are actually there or not, by asking for more specific questions and all that. So this is called mixed reasoning. So this was a very, very powerful way to make use of these rules, apart from the fact that it is readable. There was one more interesting thing that happened, because particularly in areas like medicine, I'm sure that's also the case where many other the knowledge itself is not very 100% sure. So if this condition and this symptom and this thing, then there is a good likelihood that you have this disease. But it's very difficult to put 100% certainty. Yes, you have this disease only, I should treat that, right? So how do I capture this relative uncertainty? So similarly, if you have a sedentary lifestyle, you are vulnerable to heart problems. If you have a kidney problem, you might have something. So these kind of things which are marginal strengthening of a hypothesis, or something which is to say it it could be indicative of this, or it could lead to this. How do I indicate that kind of things? So if then rules actually came up with very interesting simple calculus called calculus is not to mean your traditional calculus, some computational framework to capture this kind of uncertainty. The mechanism was to attach what is called a certainty factor with each of the rules. So I say that if you are hypertensive, then you are vulnerable to heart disease with some 0.1%. If you have a managerial job, then you are vulnerable. And if you lot of these conditions kind of are all present, then your vulnerability actually is has a much higher value. So there are simple mechanisms to aggregate these certainty factors to help in your reasoning. So a simple human intuitive way of capturing uncertainty in the domain as well as in the input was also something that would be comfortably supported through the if then rule mechanism. Okay, so these were some of the strength, and of course, where the challenge was, when the number of rules are large, ensuring whether these rules are all consistent, whether they are duplicating something, something is subsuming something, something is contradicting something, that became a challenge, and that is one of the reasons why when it became a large set of rules, it became very difficult to maintain and ensure that the rules are proper. and that kind of eventually led to the downfall of the field also. But I think these concepts are important, and I'm sure there are many applications, even particularly with today's computing capabilities and all that, where this idea can be exploited. Okay, so take care. Thank you.